Hello everyone. Let's see. Hopefully people will start joining. We had some technical difficulties getting stuff going, so thank you for your patience. You would think as a millennial I would know how to work Instagram, but I guess I don't. So I guess we'll wait maybe just a minute or so, but I just wanted to let you guys know that I am at Interlaken Park, and there's a whole bunch of cool chalk artwork here right now. So there's the Black Lives Matter sign and a whole bunch of other kid art. So that's one thing I've really appreciated about, this quarantine time, is the community has really come together to provide resources for one another, and especially for parents. So there's a box with chalk and a lot of great artwork. So hopefully the rest of you can get that going at your local park as well. So I'm going to flip it to me. Hi, I'm Amanda Bidwell. I am a volunteer with Green Seattle Partnership, and then I also did some consulting work with them 2 years ago, where I looked at moss in 25 different Seattle parks. So we're kind of going to go over what moss is, the history behind why it establishes, and just some cool tidbits about it. So I guess we'll get started because we kind of have a critical mass now. So here we are at Interlaken Park. So Interlaken Park is an active restoration site for Green Seattle Partnerships. I think most of the park is either 2, 3, or 4 restoration phase. So you see a pretty mature stand here. You see a lot of moss up in the trees. We'll get a closer look at that in a little bit. We'll start right here because here's some. So just kind of a basic overview about moss. So moss is a bryophyte. So it's in the same group as liverwort and hornwort. And so here's some mighty fine looking moss growing up the side of this tree. So moss has been around for a very long period of time. It's been around it showed up as early as 298 million years ago, right around the same time as algae was making the move from the water to land. So it's one of those primary colonizers, both 298 million years ago and now. So it's considered to be one of the first species that comes in after a catastrophic event, whether it be Mount St. Helens, another volcano exploding. They come in and they can colonize right away. So they can establish on the side of trees, they can establish on the ground, and even on concrete and bare rock. So they're able to break down and kind of expose the substrate and release nutrients for the next wave of species that comes after. So just a quick overview. So we have moss that we see here in the Pacific Northwest, and then there are other species of lichen and air plants that are sometimes referred to as moss. So Spanish moss is not moss. The quintessential quote-unquote moss that you see draped on old growth trees in the south, on live oaks and bald cypress, that's an air plant. It's not a moss. Then there are 2 types of lichen that are commonly referred to as moss. That's old man's beard and reindeer moss, both of which are lichen that grow in temperate forest ecosystems as well as in the boreal forest ecosystem. So here's some good moss. So we'll just stop here for a second and I'll kind of go over some basics. So moss is a non-vascular flowerless plant. So as it's non-vascular, it doesn't have a xylem or a phloem. So it has to use a different structure to transport water throughout its structure. It's often referred to as a lower plant because it is considered non-vascular. It has no roots, but instead it has rhizoids. So if we kind of pick up these tiny little sections right here. So this is a mixture of stuff, but if it's going to focus, you see those brown bits. Those are decomposing bits of the moss, and then also rhizoids. So rhizoids, unlike roots, they don't transport water or nutrients, but rather they form a a structural bond that allows moss to attach to a surface that it's on. It's a small hair-like structure that helps with anchoring. So this is a structure that is incredibly prone to drying and wetting cycles. So it's rather soft and springy since it goes in and out of moisture regimes. So it's less rigid than typical roots would be. Moss is also an autotroph, so it needs sun in order to photosynthesize. And as I mentioned earlier, it's a flowerless plant. So it doesn't produce via via flowers or seeds, rather it reproduces via spores. So right here, I don't really see any spore bodies, but moss for the most part only has spores show up on occasion, and it tends to be towards the end of its growth life cycle. And they are attached to the base of the gametophyte, which is essentially the leaves, this green bit of the moss, and it depends on the gametophytes for water and nutrients. So here we have a mixture. Oh, how long is their growth cycle? So most moss that you see out in the world is maximum 3 years old. Most moss, but you have some species like Helicomium, which tends to grow in boreal ecosystems. We're probably not going to see any here because it tends to be in less polluted, cleaner regimes. But it can live for up to 25 years. And that's one of the moss, it's called stair-step moss. So you see years of growth, almost like you would see tree rings. So what makes moss really cool is that it's only one cell layer thick. So it absorbs all of its nutrients across this entire cell layer. It kind of acts as a sponge. It also lacks the impermeable waxy coating that you would typically see on a lot of other leaves and plant structures. So water is the limiting factor in its establishment, in its growth, and in its ability to receive nutrients. So it kind of acts as an intermediary between the sky and what's happening in the air and the substrate that it's growing on. As I mentioned, water is a limiting factor. So it's been shown that sphagnum moss growing in peat regions, so in Norway, Russia, and Canada, can absorb 20 times its dry weight in moisture. There's a little ducky right there in the tree. So it needs water to survive, and that's why we see so much of it here in these iconic Pacific Northwest forests, the moss-draped image that you see when you're out on the peninsula in Western Washington or in Western Oregon. So moss is incredibly resilient to desiccation and rehydration. It can go for months at a time without water, where it goes into a dormancy phase. And within a few hours of hydration, it can go back to normal. So as I mentioned, moss absorbs nutrients from the atmosphere, and it has been used for a long period of time as a bioindicator for air quality, particularly in Europe. So we'll get into a little bit more about that later, but I'm going to find a good log with a couple of different species that we can start going over stuff. So moss, another thing that makes it really cool is it has a high cation exchange capacity. So this is the ability for the moss in the cell itself to hold on to exchangeable positive cations such as potassium, ammonium, calcium, magnesium, manganese, anything that has a positive charge. It plays a big role in biogeochemical cycling, particularly in the boreal forest and in the Pacific Northwest. If you look up into the canopies, let's see how well I can zoom in for you. You can see all of this moss up there, and that's serving a very important ecological niche. It's allowing for the establishment of other organisms. So you'll see ferns growing out of moss because as they slowly start to decompose in the tree, they form what is known as a canopy soil. In particular, where you have some of the crotch-like structures in the tree, that's where you'll start to see some soil development and more organisms growing on top of it. So moss are epiphytes. They grow, particularly here, they grow symbiotically on other plants. They're not parasitic. So you see them on a variety of tree species here. Other epiphytes include ferns, lichens, and in tropical rainforests you will see orchids. So that's pretty cool. So we are going to start here. So this is just along the path. But as you can see, there's a whole bunch of moss just growing right up on the side of this tree. So here's what I was talking about with this soil formation. So within this, if we're lucky, we'll see something move around. You have a whole bunch of microarthropods that live in here. So what is absorbed in this moss is being transferred into this soil as it decomposes, and then the microarthropods are eating that. And you kind of have this whole trophic cascade that can come out of the moss because the microarthropods are then consumed by larger insects, which are then eaten by birds, which then can kind of scale up from there. So a couple of years ago, I had a colleague at UW who was looking at microarthropods that live within these moss communities and how they were responding to higher levels of pollution. So here, this is Dicranum. This is a species you don't see as much of in the city, but it's growing right here. You will see it grow extensively on Doug firs out on the Olympic Peninsula. You also have some Kimbergia, which is right here. This is a mixture of several different species. And then you've got some Homolotheum, which uses a branch-like structure to grow. Oops, sorry, I'm falling into a hole here. So as I mentioned, moss can be one of the first colonizers in a lot of different ecosystems, and it can help with soil stabilization as it starts to anchor some of the rhizoids into the soil substrate itself. And it can also insulate the soil, so it can help with hydrologic regulation and help keep certain soils a bit more moist than they may have been otherwise. These rhizoids, as they dig down into the soil, can also help with soil airspace, which is incredibly important as well. It depends on the soil structure that you have. It's also, interestingly enough, in World War I, peat moss, which we don't have in this particular park here, was used as a surgical dressing. I just found that out yesterday because of its antibiotic properties. And so it's been used extensively for a long period of time, not only by organisms in the forest, but we have used it for surgical dressings. Peat moss has been used as a fuel in the Boreal region for a long, long time. So one thing that I kind of alluded to earlier is that moss get all of its nutrients from the air. So it's able to act as a bioindicator, a biomonitor for air quality in a particular region. So they absorb nutrients, and as I mentioned, they're max 3 years old, so they kind of provide a good snapshot of what's been happening in an ecosystem over a period of time. So if you have more pollution, whether it be through wet deposition or dry deposition, that can land on the moss itself and then slowly be absorbed into the tissue. And then some of it is used metabolically, but most of it doesn't need the excess of nutrients. So it then takes those nutrients and kind of holds onto it like a sponge would. So it provides a snapshot of what's been happening in a region over a period of time. There's been an extensive use of moss for air quality monitoring in Europe. It's been going on since at least 1990, and it's been funded by the EU. So the EU has had, it's ranged, it's every 5 years they go out and collect samples of moss across Europe, and anywhere from 20 to 36 different countries participate. So they have a long-term record of moss and pollution levels over time. During the consulting work I did with Green Seattle Partnership, what we did is we went out to 25 different parks. We collected Orthotrichum lily, which I'm trying to find some of it. It's Sarah Jovan at the Forest Service calls it the Twinkie of the moss world, because it can live in pristine environments and it can also live in the dirtiest of places. It thrives no matter what. It has really exploited a niche. And Orthotrichum is a moss that you can see pretty much anywhere around here, except for right now when I'm trying to look for it. Let's see. Here it is. Okay. This is Orthotrichum. So this is what it looks like when it's wet. When it's dry, it definitely is a little bit browner and it has a smaller texture to it. It's more closed up, but it grows extensively in urban ecosystems. So we used Orthotrichum for the study with Green Seattle Partnership, where we collected samples. So we collected both moss samples, which give us kind of that snapshot of what may have happened. So we can track old emissions through what's been absorbed into the moss tissue. And it can also collect, you can have a peak influx of metals or pollution absorbed into the moss tissue after a rainfall event. So we collected moss and we also collected soil. So we wanted to look and see in these parks what the soil metal concentrations were like versus what was being captured in the moss, which would have been, like I said, that snapshot period. So we were able to do an enrichment factor to kind of look at how elevated were the levels in the moss versus what is in the soil. So that study that we did is on GSP's site, so everybody should be able to access that. And it kind of started a conversation here in Seattle around the ability to use moss as a monitoring tool. As I mentioned, it had been used extensively in Europe and continues to be used in Europe, but there hadn't been much work here with moss as bioindicators up until a couple of years ago. During my master's research, I started to look at Canopy Moss. So I was looking at isothecium in big leaf maple trees, both on the peninsula. So the Hoh Rainforest was my quote unquote pristine site. I mean, we all know nothing is truly pristine anymore because I found lead signatures coming all the way from Asia in moss samples that were on the Olympic Peninsula. And then I compared the levels I was seeing in those quote unquote pristine sites to what we were seeing here in Seattle. So Interlaken Park was actually one of the parks that I climbed trees in. So I have an affinity for this park because I've been up in the beautiful big leaf maple canopy here. So we're gonna head up here so we can hopefully find some more moss. So, as I mentioned, the Green Seattle Partnership study kind of sparked a conversation here. And I was fortunate enough to work with Lisa and Michael and Eric to, collect the samples and present the results. So the results were then shared with the community, with other departments within the city, and it sparked a conversation with the Forest Service because The Pacific Northwest Lab of the Forest Service had done a study in Portland using Orthotrichum as an indicator. So what they did is they had a gridded study across all of Portland where they set out in neighborhoods. They did a grid across the whole city. They went out and collected grab samples, I believe during the spring 2015, 2016. I would have to look at the study to verify the dates, but they wanted to see, can this be used as a low cost way and as a proxy for air pollution. So one thing that's really important to note is the values that are in the moss are not absolute concentrations of pollution. They allow us to screen areas where there are higher levels of pollution, but there is not a one-to-one direct comparison between what's in the moss and what is in the air, because as I mentioned, moss has its own metabolic reasons for storing some different cations, but it does provide a good screening tool for us to use. So in Portland, they were able to identify, I think, 3 or 4 different hotspots across the city where they saw elevated levels of arsenic and cadmium, I believe, which when those two are found together tend to be common in glass smelter facilities. So they were able to go out, do this broad screening with, I think they collected 345 samples, and they were able to zoom in to those areas and then do some additional follow-up where they worked with the Oregon Department of Environmental Quality, which I guess would be the equivalent of either Puget Sound Clean Air Agency or Department of Ecology here. And they installed air quality monitors so they could look over a shorter period of time to see if what they saw in the moss was indicative of particles that were in the air. And those instruments that they installed, the air quality monitors, cost hundreds of thousands of dollars, not only to purchase, but to maintain. So because they were able to zero in on where some of these higher levels of metals were happening, they were able to utilize the resources most effectively to zoom in and narrow in on the potential sources of pollution. Turned out that it was 2 glass smelter manufacturers, and so those which that hadn't been as regulated before, the particular pollutants that they were doing through stained glass, and now they have some regulations around that, and it's really been amazing to see how the community reacted there and what happened. So there was a recent study here in Seattle. So not the one with GSP or not the part of my master's project, but it was the Green Duwamish Learning Landscape. So it was a group of university members, governmental agencies, community nonprofits that came together to use moss as a screening tool last summer, so May and June of 2019, in Georgetown and South Park, 2 areas that we know tend to be more polluted than the rest of the city. So we partnered with Duwamish Valley Youth Corps, U.S. Forest Service, Just Health Action, City of Seattle Office of Sustainability and the Environment, Western Washington University, Duwamish River Cleanup Coalition, and Dirt Corps to collect moss. So we trained Sarah Jovan, the researcher at the U.S. Forest Service, and myself went and trained 29 Youth Corps members, I believe it was 29, last summer. So they went out and collected the moss sample, and then were able to collect the moss, learn the methodology and process behind a scientific investigation. and also processed some of the lab samples. So we prepped them before we sent them to the Forest Service lab. We ultimately wanted to test if a community-based collection was a viable way of looking at science. So we had them collect samples, and then I went out and collected additional samples to kind of verify that the levels we were seeing in their moss from the same tree were the same. We analyzed them for 25 different metals at a U.S. Forest Service lab in Minnesota. And surprise, surprise, the levels we found in the Duwamish Valley for arsenic, chromium, cobalt, and lead were higher than samples collected in city parks. And arsenic and I think chromium were much higher in those neighborhoods than they were in the Portland study. So that was pretty interesting find. So we did a gridded design across Georgetown and South Park. So these results have just come out. So I would recommend individuals going to Duwamish River Cleanup Coalition's website. They have a press release that they put out with the main takeaways. But as a result of the levels that we found the highest levels of arsenic and chromium and lead in the industrial areas of those neighborhoods. So along East Marginal Way, along by South Seattle Community College, the triangle down there, and by several different businesses. The levels were lower in residential areas, which is great, but they were also higher than what they are typically in other parts of the city. So as I mentioned, you guys should all go check out the press release for that study. That person just ran past very fast. I can send Maya the link, and hopefully she can post it on GSP's Twitter or Instagram, because it's information that needs to get out there. The results were presented to several different agencies, so the City of Seattle, as well as Puget Sound Clean Air Agency. So now the next steps are working with Puget Sound Clean Air Agency to install some monitors. They do have one monitor in the Duwamish Valley area, but I do not think it collects metal concentrations. It more looks at ozone, CO2 levels, nitrous oxides. So getting a monitor down there that would look at heavy metals is kind of the next step. So that's all under works. That's in the process of happening. I believe the press release goes into a bit more detail about that. Yeah, so I'm very curious to see where it's going to go, and hopefully, depending on funding, I know right now with COVID and everything going on, budgets are pretty tight, but this is something that needs to happen. And from an environmental justice standpoint, something that's been needed for a long period of time. Communities of color who live in South Park and Georgetown have known for a long time that their air is not clean, and they want resources and action. So hopefully this will kind of be a catalyst to help provide tools for additional funding. So fingers crossed all of that happens, and we'll see where things go from there. So yeah, I'm going to see if I can find some other species. So here we have a mixture of, you got Homolotheum, which is, let's see, this one, this tuft. It tends to grow on a branch-like structure. And then you've got Kimbergia, which you tend to have one individual shoot and rhizoid attached to it. The Homolotheum, this one, tends to have the rhizoids grow like this out, and it branches off from there. Now, I'm sure many of you have heard the saying that, if you're lost in the woods, look for moss because it grows on the north side of the tree, which, in general, that's a good practice. And it's assumed that you want to look at moss on the north side of the tree and that it will grow there. because of the sunshine on the south part of the tree, which can create drier environments. But it ultimately will grow wherever it is damper. So sometimes the north side of the tree, if it's shaded, is damper. Sometimes the south side of the tree is damper, so it'll grow there. You should always have your compass with you, is the takeaway of that. One other interesting tidbit is that moss that grows on roofs ultimately isn't as bad as most people think. As I mentioned, it has that rhizoid structure, which allows it to anchor, but it, for the most part, doesn't cause as much damage as people think. What it does do is it can decrease peak stem flow during storm events, so it kind of acts as a hydrological buffer. So instead of water just going directly off of your roof, it kind of slows it down and lets it trickle off in a more gentle way. So I know some people really don't like moss because they think it's a nuisance, but moss is pretty great and serves a very important ecological purpose, particularly here in the Pacific Northwest. So I mentioned that in Europe they've done moss monitoring studies. Another thing they've done is moss transplants, where they've taken moss from quote-unquote clean areas and transplanted it to trees or in moss bags in urban environments to kind of look at how long it takes for metals to accumulate. So one study in particular, in Spain, it took 1.5 years for a transplant from a polluted area. So say this was in Spain, so in Madrid, they took a sample from like downtown Madrid, took it to the forest, and that only took a 1.5 years for the polluted moss from Madrid to reach background concentration levels in the clean forest. In the other case, when you brought the clean moss into Madrid, it only took 240 days for the clean moss to reach polluted levels. So it can happen pretty quickly, but like I said, you know, it's a snapshot of what's being collected there. One of the most important things I forgot to mention, and I say this because I'm a little biased when it comes to the nitrogen cycle. One of the chapters from my master's research project was looking at moss, not only for metal levels, but also for the presence of cyanobacteria. So cyanobacteria can fix atmospheric nitrogen and convert it into a plant available form. So in old growth forests that people tend to believe are nitrogen limited, it provides a great source of nitrogen. So I was able to go out to the Hoh rainforest, collect 3 different species, isothecium. So isothecium you will find in the city as well on the peninsula. And I was able to collect those species, plus on the peninsula I collected helicomium and antotrichia, which you don't really see either of those here. Those need very clean environments to thrive. So I collected them. I ran acetylene reduction assays to look for nitrogen fixing bacteria to see if over the course of a day, if they would fix nitrogen. And both in the city and on the peninsula, they did fix nitrogen. The peninsula having a larger quantity of fixation happening. But you'll see here, you've got tufts of moss that drop to the ground. So is there cyanobacteria and nitrogen fixation happening there? Then it slowly decomposes and makes its way into the soil. In the boreal forest, it's a sizable amount of nitrogen that ends up coming from moss cyanobacteria relationships. And yes, I do have a moss resource book. Yeah, I just got to get it out of my bag. So, I'm sure many of you are familiar with this book, Plants of the Pacific Northwest. There's moss way in the back. So there's a lot of good ones in here. This will be the most common species that you find. So this is actually Isothecium, so you'll see it on a whole host of different trees. But yeah, so I would recommend this book. And then if you can find this one, this was a little bit harder to find, but Moss, Lichen, and Ferns of the Northwest. A lot of great resources in here. Highly recommend if you can get your hands on it. But yeah, these are great. The U.S. Forest Service has a lot of great moss identification and lichen identification material. So that they're always a good source of resources and material. But yeah, I think that's what I had for today. I hope everybody's able to get out at some point today, since it is nice, whether you are going to protest peacefully or just to get out in the woods for the day. Highly recommend it. And if you can find a forest in your neighborhood that has some moss, I encourage you to get mossy with it and enjoy. Okay, thanks guys.